I am Srinath Raghu, presenting the project for machine learning model for the combined cycle power plant. Project objective of this project was to build a stable, consistent, robust regression model to predict electrical energy output. Considered multivariable linear regression model and compared with nonlinear regression model. Nonlinearity was captured squaring independent variables, as you can see, and also factored interaction between temperature, relative humidity, and vacuum. The R squared was used to measure the proportion of the variance in the actual values that is predictable from the independent variables, and root mean square was used to quantify the average error of the model's prediction. I would like to screen share the modeling exercise that was performed on the CCPP dataset that was provided. As you can see, 9,568 hourly average ambient readings was provided. I divided manually into two sets, 80% for training and validation and 20% for held out for final test of the model, and divided the 80% into five validation sets, K4 equal to 5, manually split the data and used it for training and validation. Applied the first validation set against the MVL model and used the regression capability of Excel data analysis, ran it against the rest of the four folds on the training data set and generated the coefficients and the intercept. The proportions were applied against the first validation set and predicted the value, and went ahead and calculated root mean square and R squared. Repeated the same operation, same exercise on the nonlinear model. As you can see, there's a prerequisite step that I had to perform. Prepared the data of training dataset and the validation dataset by squaring the independent variables and also multiplying the two dependent variables to capture the interaction. Ran the regression analysis on the nonlinear model, generated the coefficients and the intercept. The proportions were applied against the against the features of nonlinear model and predicted the values. As you can see, the proportions were applied against each of the features and added the intercept to predict the values. Went ahead and calculated the root mean square and R squared. I iterated this operation or exercise on the second data set, validation set, ran MVL model and a nonlinear model. I iterated through the same exercise on the third validation set and fourth validation set and fifth validation set. Finally ran the model against all of the training validation set and trained the model and generated the coefficients and the intercept, which was applied. The proportions was applied on the held out test data set and predicted the values, and went ahead and calculated the root mean square and R squared. Finally, I summarized all of these results, as you can see, for both the models, performance and five-fold cross-validation performance, and also performance against held out test set, you can see that MVL model for root mean squared has been slightly lower consistently as compared with nonlinear model, and R squared is slightly higher than nonlinear model. I will cover the model interpretation and conclusion in the next slide. Thank you. Model interpretation and conclusion. As you can see, MVL model performed slightly better during the cross-validation phase and outperformed the nonlinear model in the final held out new unseen dataset. In conclusion, MVL model is more stable, robust, demonstrated better performance as compared to the nonlinear model, and it's a superior choice. Thank you for listening.